The European Brain Area Research Project, EBRA, was created in November 2018 as a catalyzing initiative for brain research stakeholders, as there are researchers, clinicians, patients, governments, funders, and public institutions, to streamline and better coordinate brain research across Europe while fostering global initiatives. The partner institutions are the European Brain Council, the Human Brain Project, the Joint Programming on Neurodegenerative Diseases, and the Network of European Funding for Neuroscience Research, which is NEURON. NEURON's task as project partner is to accelerate excellence, innovation, and translation, and foster the exchange by promoting open science and quality assurance in research. So why are we promoting this? Brain research in Europe is a rapidly evolving field, and investigating the complexity of physiological brain functions and brain diseases fosters the development of novel tools and approaches towards a better understanding of basic brain functions and generating opportunities for novel therapeutic approaches. To address and promote open science in research, it is necessary to broadly inform and support the research community in the implementation of future pre- and clinical research that is credible, contributory, communicable, and conforming. The implementation of open science requires compliance of preclinical as well as clinical research with standards and guidelines on design, conduct, analysis, and reporting of results. The implementing of open science and quality assurance is for NEURON a key issue in current and in future research proposals and in grants. In December 2020, the EC published a reproducibility report. In the past decade, the recognition increased for the need to address inefficiency of the research process. To avoid useless and costly repetition, which is the most important item for funding organizations, because we invest taxpayers' money and regard it as unethical to sacrifice small animal numbers several times instead of one confirming approach. We aim to facilitate the translation of results into innovation. Excuse me. These objectives can be pursued by increasing the openness and the transparency of all steps of the research process, and to help increasing the likelihood that research and development results will be valid and therefore reliable and reusable. Also, the lack of reproducibility has a negative impact on public trust in the conclusion of science. The trustworthiness of research results is crucial for scientists and indispensable for citizens. And to foster the positive perceptions of science, it is of utmost importance to implement open science and the fair data principle, which is a set of old and new practices aimed at enhancing the scientific process. There are many high-profile examples of lack of ability to reproduce major findings, such as this one. In the world of animal use, experimental design is a big issue and reproducibility a key element for the translation of work with animal models to clinical applicability. And this is wider than just animal research and encompasses things like culture change and also incentives. Major implications for the whole of science touch our credibility with the public and the government who provide the funding, but are also important in relation to the public acceptability of animal research and also the attempts of certain animal rights groups to discredit animal work. So in 2018, these are the greater issues of why is NEURON in EBRA interested. in working in promoting these goals. We started in 2018 the cooperation with the Quality, Ethics, Open Science and Translation Center at the Berlin Institute of Health. And we had a pilot workshop in January 2019 with 220 attendees, which was very well received. We had our first early career research workshop and as a spring school in March 2020. And we had a second early career researchers autumn school in October 2020. We are planning for 2 more events in 21, which is this year, and hope from many participants from NEURON funded projects. So I'm therefore very happy to welcome for today 3 different talks. I will introduce you now the first speaker, and before the second one, the second, and before the third, the third. This is Professor Dr. Ulrich Dirnagl. He's the director of the Department of Experimental Neurology. He's also the Chief Executive Director of the Center for Stroke Research. And among other honorable posts, he's also the founding director of the Quality, Ethics, Open Science and Translation Center at the Berlin Institute of Health. And with that, I hand over to Professor Dirnagl, if you please.
Okay, so can you hear me now?
Yes, thank you.
So, and let me just, before I start, I need to share my screen properly. So I hope you can also see the screen now. Okay, so thank you very much for the introduction. Also, thank you for organizing the workshop and for giving us a platform to talk about these things. And as you have pointed out, I think they are very relevant for all of us working in biomedical research. So today, and it's kind of my summary, if you wish, together with Daniel Strech, who will give the talk directly afterwards, we want to bring to your attention 2 issues which have to do with ethical imperatives. And that is that the trustworthiness and the usefulness of preclinical research are in fact highly relevant in an ethical sense for human welfare, which is what I'm going to be talking in the next minutes. And that's kind of well, might be a bit of a surprise, because normally we talk about this in the context of animal welfare. And this is what Daniel will talk about. But he will sort of look at it from a different perspective and tell you that in the current 3R concept, there are a few important things missing. So why is it that preclinical research there is an ethical imperative that goes beyond animal welfare? I think that's pretty straightforward, and that is because preclinical experiments are typically cited to justify the initiation of clinical trials. Clinical trials are very often based on preclinical findings, so they need to be robust. They are the foundation. Bench to bedside translation, in this sense, is the true mantra of modern biomedicine. We write about it in our papers, in the introduction, we write about it in our proposals and so forth. And there's one minor thought that I would like to share, and that is that preclinical results actually quite often are used to justify compassionate use and off-label use of drugs. So a mouse result may become directly important for humans. Now, my personal perspective on this is that I'm a stroke researcher, and this is a field where we have killed millions of animals over the last decades. There are thousands of researchers globally. We have found hundreds, if not thousands, of highly effective therapies in our animal models. We have also conducted and tested these drugs in human trials and have basically not found them to be effective. And in all this, we have spent billions. And actually, we have achieved, I have to say, very little for our patients. Now, you're in mental health, I guess, most of you, and to you, this may not be so interesting, and you may argue that the stroke researchers are just a bunch of not so good researchers. So I have a quote for you from Tom Insel, who was the head of the NIMH for quite a while, for quite a time. What he said is, I spent 13 years at NIMH really pushing on the neuroscience and genetics of mental disorders. And when I look back on that, I realized that while I think I succeeded at getting lots of really cool papers published by cool scientists at fairly large cost, I think 20 billion, I don't think we moved the needle in reducing suicide, reducing hospitalizations, improving recovery for tens of millions of people who have mental illness. I hold myself accountable for that. And I understand what he's saying, and I hold myself accountable for that issue in stroke. So if you wish, there is good news. And the good news is that meta-research has identified numerous reasons why preclinical research results may not translate to patients, and in fact, that we often waste resources and potentially jeopardize patients for no good reason, and they're potentially remediable. There are many other reasons, and some of them we cannot address, like biological complexity, but these we can. And so here's a list of, there are many more things, but to me, these are the most important ones. So I want to talk about these here on the list. And I will not talk about publication bias, which would be the last point, because this is what Daniel will also cover. So failure to reduce bias, what does this, in experimental designs, what does this mean? This is from a tremendous analysis. It analyzed 1.6 million papers on preclinical research over the last 10 years. And what you can see is that the reporting of randomization, which hovers around 30%, and blinding hovers around 10%, which is exceedingly low and demonstrates that there may be quite some bias that is active in preclinical research. Does it matter? Yes, it does. We can easily show that. We have done this, for example, in this study led by Malcolm McLeod, where we just checked papers in stroke research, experimental stroke research that tested a specific intervention, one drug, and we compared the effect sizes of those that did blind the conduct of the experiments and those that didn't. At least they wrote about that they did or didn't. And what you can see is that those that do not report blinding find double the effect size in the same paradigm with the same drug. So I think it is highly relevant. The second issue, I think, is about statistical power, and it's exceedingly low in this type of research. Again, an example, very recent paper analyzing stroke research. They found that preclinical stroke research has an average power, experimental stroke research, an average power of around 10%. Remember, clinical trials have to have a power of above 80%. A coin flip has a power of 50%. So this is dismal. And this is also reflected in this analysis, which I've already shown you earlier, looking at the entire preclinical literature, and it shows that it's around 10%. So what does this mean? It means that we, in these cases, we see not only a very high false negative rate, which we all know with low power, it also means that we get a very high false positive rate, which must be above 50%. So hence we're looking at lots of false positive in the literature. And if there is a true effect, we see a tremendous overestimation of the effect size on the order of 100% on average. A third issue, obviously, is, and we all know this, are questionable statistical practices like data dredging, like p-hacking, like harking, which is hypothesizing after the results are known. Why do we do this? Because we have a strong bias against the null hypothesis. We just don't want to find what we don't want to find. And so if we get a result that is a little bit sort of close to statistical significance but did not cross it, we tend to repeat experiments, we tend to add animals or repeat statistics with different tests, which would then be p-hacking. We remove outliers, so we are nudging effect sizes in proper directions. We try different strategies. Well, the antibody, we don't know, was it specific? Let's try another one. Claim that the previous one didn't work, and so forth. Once we have accomplished a p-value of 0.05, we don't talk about this. We just stop there and we publish, and we move on to the next paper. have you ever heard someone who had a statistically significant result and then actually said, well, this is actually very unlikely given what I just showed you, let's repeat it? Well, you'd be crazy in the current system to do that. A fourth issue is, and I think this may also be a very problematic issue in research on mental disorders, is low external and construct validity. In stroke research, we look at black male, healthy, black 56 mice, and if you kind of transpose this to a human cohort, they would actually correspond to a cohort of healthy pubertal male twins. They are inbred, raised on a very small space in an isolated tent. We have SPF conditions, specific pathogen-free, and we treat them. We feed them with an enriched granola diet loaded with vitamins and everything. We all know that this is not the cohort we are looking at when we study stroke patients, and I'm sure you must have similar concerns if you look at autism studies, if you look at schizophrenia studies, especially in mice. Now, a fourth issue in external validity, another one, and that's very rarely talked about, is the immune system. And it's now totally clear, and there's very nice work on it, that shows that animals raised under laboratory conditions, that is mostly SPF, have a totally immature immune system. It's like newborns, even if they are 2 years old, which is aged in their world. Now, so we are basically studying babies and pretend that these are adults, and the systems are completely different. Publication bias will be covered by Daniel. So this was a tour de force through, I think, issues, and many of them have been described over and over. I think we're well aware of them. Most of us know them from their own work. I can tell you, I did all this myself. So we know the problems. So what can we do about them? Most of these things are actually no-brainers, although, well, they come with some issues. One is some of it is more resource intense, and the other, our results will, on average, not be as spectacular because many of our studies will turn out to be nulls. So that is maybe the reasons why we're so reluctant to adopt it. So, but what can we do? We can, I will go through them bit by bit. So increase internal validity. What does this mean? We need to take care of selection bias by randomization. We need to take care of performance and detection bias by blinding. I have not talked about attrition bias. So this is something we take care of by predefining in- and exclusion criteria. This is extremely straightforward. A bit more problematic is to increase construct validity and external validity, but it is possible. And so we can study aged animals, we can study animals with comorbidities, we can study outbreds, for example, to get genetic heterogeneity. We can even study animals with a normal immune system. That is a bit more tricky because we need to expose them to a normal microviral fungobiome. There are models now, and a very nice example for this is what Stefan Rosshardt does he's in Freiburg now, and we collaborate with him on this, and that's extremely important work in this regard. We need to increase the sample sizes. Well, of course, you may argue, rightfully, that this is easier said than done. I mean, that we may get into problems getting permissions for those for our results, for our studies, because it may be argued, well, you have always used 8 animals, now you say you need 20, what's going on? One way of dealing with these issues, and that's true for heterogeneity, which we need more, and also for sample sizes, and maybe also for different flavors of models, is team science. We need to do much more team science. And I think consortia like the ones that you are in, and that is the ERANET is organizing, I think are a brilliant opportunity for this. We need to replicate and we need to conform pivotal results, just like in clinical science, where you need to have a phase 3 or 2 phase 3 trials to get a drug approved. We should really replicate and confirm critical pivotal results before we take them into the clinics. This is possible, it is publishable. This is just an example where a consortium in which I was involved did this for a drug that was also tested in MS clinical. It was the clinical testing was done actually while we did this. It turned out to be negative, and our multi-center trial, our preclinical one, also turned out to be negative. But of course, you could ask, why do you do that afterwards? It's flip-sided. We should do it the other way around. An argument that we often hear, and that is true, is that it's very hard to finance stuff like that. So it's very good to hear that there are funders out there. This is an example from Germany. The BMBF is funding confirmatory studies. I know other funders in other countries who have started doing this. I think this is the way forward. This makes this not only financeable, but also gives it the prestige that it needs. And I can also tell you another benefit of this is in the collaboration. You learn so much about the modeling in other laboratories if you open them, if you exchange your results. This is extremely, these are extremely positive experiences that we all had. So the bottom line of this is, I think that low quality preclinical research is unethical. And this is because we are building a foundation that is not trustworthy, that is not robust, on which we then build. We're not only eating up resources for no good reason. We may also endanger patients, which we send into trials for drugs that in the first place didn't work. We just thought that they are working, and so forth. So there is this ethical side to it, which I think we need to be aware, those of us who work in laboratories, who work on preclinical models. It's not only about animal welfare. So I'm already at the end of my tour de force. I wanted to give us a bit more time for discussion. I would like to just finish with a moment of self-reflection, also maybe trigger some bad dreams, if you wish. If you think about your own work, how are you faring in this? Do you randomize? Do you blind? Do you report inclusion and exclusion criteria and work by them? Do you have data management plans? Are your sample sizes adjusted to getting robust results, minimizing false positives and false negatives at the same time? What about your statistics? Is it pre-registered? Are you involved in confirming pivotal results? Have you published your null results? Are you planning to do so? And what really is what do you know about the external or construct validity of your own work? I don't want to blame you. I have had bad dreams, and I still have bad dreams because it isn't easy. But I think many of us have started to tackle this, and we can do it together. So I think this is where my presentation ends. And I think after Frau Lichtenberg has introduced Daniel, we should continue with Daniel's talk because it's very closely related, as you will see. And then we will have plenty of time to discuss them together. That would be my suggestion. So I'm stopping my presentation here and hand over to Frau Lichtenberg again.
Well, thank you very much. And as you said, also I suggest that we first hear the next talk and then discuss those together. And I have now the pleasure to introduce Daniel Strech. He's a professor for translational bioethics at the Charité University Medicine Berlin, and he's also the vice director for the Quest Center at the Berlin Institute of Health. So I stop my presentation and hand over to Daniel Strech, if you please. Thank you very much.
Yeah, thank you also from my side very much for the invitation. And yeah, and great that I have the opportunity to just follow on what Uli introduced. I hope you understand me and you see my screen already in the presentation mode, I hope.
No, it's not yet presentation mode. Yes,
No.
that's it.
Yeah, I follow what Uli presented, because I come back what he mentioned early in his presentation, that we both worked on a brief conceptual piece that more or less says that the animal ethics is about safeguarding the welfare of animals, but another second important basic principle is that animal ethics is about safeguarding also the value, the scientific value of the research. Without scientific value, animal research is also unethical. And we try to make this easy to understand, so to say, with regard to this figure, saying that, look, currently worldwide, the most established framework for animal research ethics is the 3R approach. Replacement, reduction, refinement, that you all know. And all these three principles, replacement, reduction, refinement, are in a certain way guiding principles to fulfill the overarching goal of animal welfare. The scientific value of a study does not build part yet of this official framework. It might be that some local, maybe even national authorities say something about the robustness of animal studies, or the necessity to register or report results, but it doesn't build part of this overarching framework. And we would argue there are these complementary three principles: robustness, registration, and reporting, that together build a complement framework to address the scientific value of studies. So, and Uli in a certain way already presented on the different facets and aspects dealing with the robustness part. Registration and reporting are even newer, so to say, I would say, in the international debate about animal research. And I would like to present on these two additional important principles. So I start with the reporting, and you are probably all aware that over the past years now already there has been a debate, of course, about the quality of reporting. If results are published, then we now have also reporting guidelines, and we can of course improve the value of our studies if we comply to reporting guidelines that help to make the paper presented in a way that is most useful for the readers. However, we also learned with meta-research, with analyses of published papers, that so far the arrived guidelines have not arrived yet. Many papers do not adhere to arrived guidelines and so on. And just recently, also because of these empirical findings on the not so perfect implementation of the arrived guidelines, we now have a new version, the arrived guideline 2, which is a shorter, more concise version with the hope to improve the compliance to arrive here. However, my presentation here on the reporting part of animal research will not cover this quality of reporting. I will go a step back and address the question, what do we know about the reporting at all? Of course, if something is published, then we can still say comply if possible to the arrived guidelines. But what about publication rates in general? Maybe even publication bias. We don't know a lot about this. There were some few studies almost 10 years ago now. One is, for example, this survey done in the Netherlands, where they asked laboratory animal researchers about how many of their experiments become published. So this was a survey, and people had to express their opinions about this. Here, the feedback was that researchers say about 50% of animal experiments are published. There were other attempts to identify the extent of publication bias by statistical modeling. Here, for example, a systematic review on animal stroke studies again, try to assess via funnel plots and other statistical means whether there might be a publication bias because there are too many positives and negative results, undesired results are lacking. They identified a major overstatement of efficacy with regard to the publications they found. But both approaches are in a certain way, of course, indirect ways to assess the true publication rate in animal research. More recently, I'm aware of two groups that studied really a completed animal study to their later publication. So one study was done by our group and the second by the University of Utrecht. The idea was really to sample a systematic randomized cohort of completed animal studies. We did this in two sites in Germany at two university medical centers where we worked together with the people who are sharing the animal research facilities. And we followed up a little bit more than 200 completed animal studies and found finally that even after we then additionally asked the PIs whether we are true with what we found, that about 69% of the approved animal studies were combined with at least one results publication. The Utrecht group found a quite similar result with about 60% of the completed animal studies with at least one results publication. So this is new data about the, let's say, publication rate, right? It's not directly biased. We don't know whether the results are biased with regard to favoring positive results, but we know this is a publication rate. So about 1/3 of results are lacking in a certain way. However, one needs to ask whether this is really the publication rate that matters most, because it's a publication rate of, as I already said, the approved animal studies. Here in Germany, we call them TVA. It's about the application documents that you send to the authority. They approve your animal study, and then you are allowed to do the animal study. So what we found is, with regard to these approved animal studies, for 2/3 of the approved application, we found at least one publication. But you all know that the approved studies, of course, do not consist of only one experiment. In one approved animal study, you find several experiments. I assume it's the same also outside Germany. And of course, in one experiment, you then have different groups, and these groups contain, of course, many animals. So there are at least two further interesting numbers. What is the publication rate on the experiment level? We were not able to investigate this directly in our study. If you go back to the survey, this Dutch survey, they asked for the rate of published experiments. Here, the feedback was about 50%. So it can be that in some publications we found, maybe we did not find results of all experiments, but the publications only reflect some experiments. And if you go even a step further, you might ask, who knows, maybe even in the experiments that are published, maybe not all groups, not all animals are published. And this is a question that the Utrecht study again addressed. They also checked how many of the approved animals are finally reflected in the identified publications. They found a publication rate of 26%. So it means that about 3/4 of the approved animals are finally not reflected in the published literature. This is a very first result. There should be other studies trying to repeat this, follow up with other cohorts. But I think it's an important field to better understand what is going on in animal research in this regard. And it might also be that when we start a discussion about this, because I think we currently lack any theory even, any guidelines about what does full reporting in animal research mean. Maybe such a more conceptual debate will bring into a better understanding of the results that should be disseminated. And there are some that are already disseminated, the results we found. There are some results that should be disseminated, but still aren't. But it might also be, of course, that there are animals used in animal research that are, for good reasons, not necessarily to be disseminated with their results because they were for training purposes and other things. But currently, we really lack criteria and guidelines to say something about what are the results of completed animal studies that should be published. There are, of course, ways on how you can disseminate results. This is why I use the term dissemination and not directly publishing. Publishing often means, in our understanding, you go to a peer-reviewed journal and publish this there. But dissemination can also mean, of course, you go to journals who publish negative results, so to say, undesired results. But there are preprint servers, of course. There are other ways on how you can share your data via different publication ways. Here, our Quest Center just recently launched the Fiddle, a tool that helps you to identify ways on how you can liberate your file drawer data in a certain way. As I already said, data sharing is another option to disseminate data. And these are ways on how to deal with the registration, with the reporting part. Second part is about the registration. This is an even newer debate, and of course, something that is very much in the development, of course, also needs a lot of still theoretical and practical debate. But to make this framework of how to safeguard the value of animal research most useful, I think registration necessarily is something to be considered. Why? The rationale behind animal study registries is it will give us this knowledge that we currently don't have about how many studies are there that are maybe still ongoing or completed but non-reported. It might help you with planning new studies. Maybe you see that a similar study has been done already. You contact the PIs and ask why the results haven't been reported. Can they say something about this? You might save a lot of time if you avoid the conduct of studies that finally turn out to be just a repetition of something that did not work. It might also help to review new studies and so on. And it's at least an incentive for those who pre-register to then finally also report all results that are necessary to report, less selective, less biased. You know that we have this in clinical research since some decades now. There it's really much established for at least a big part of clinical studies. The question is whether something meaningful could also be relevant for animal research, maybe also not directly addressing the whole field, but starting with, let's say, the very late stage, very preclinical part of research could be a starting point. There are already now very new, so to say, but since 2 years, we have platforms that allow the pre-registration. The first one was, again, the University of Utrecht. They launched the preclinicaltrials.eu platform to pre-register an animal study here in Germany. Our German Center for the Protection of Laboratory Animals launched an animal study registry, but there are also platforms such as the Open Science Framework that allow pre-registration of whatever types of research. We did some analyses with researchers, with funders, with industry representatives and authorities about strengths and weaknesses of this. Finally, I will not go into detail here. We, of course, found several strengths and weaknesses that the stakeholder see for animal study registries. We also did a bigger international survey to test what the majority votes are the strengths more important or the weaknesses. Finally, to really condense this in a certain way, the core message is there were a lot of potential strengths that really the majority of researchers found important. So really the majority voted that yes, if we would have animal study registries, this could help with avoiding duplication of efforts, improve Also refinement and reduction in animal research, increased exchange, improved dissemination of results. So a lot of strengths that also majority found important. Few but important weaknesses were the administrative burden, of course, and the theft, the potential theft of ideas. So these are very important weaknesses for why this is probably not that quickly established. But let's think about it. I mean, there are relatively effective safeguards in place, in principle, right? There are several ways how we could reduce administrative burden. I will show this on the following slide. And with regard to the theft of ideas, of course, we can and should have embargo times. The registries that I just showed allow you to pre-register a protocol with an embargo time. You have it time-stamped, but you decide whether you make it publicly available only after you finally completed the study. With regard to the reduction of administrative burden, the core principle here would be, I jump directly to the third bullet point here. The ideal scenario would be you don't have to do something new for the registration. You would more or less copy paste all the information that you already have in your study protocol that you needed to get approval for your study or for funding. So you take the information, hopefully you had some core information also reflecting the ARRIVE 10 criteria, and then you just copy paste and you have your pre-registration. To check whether this is already possible, we did a very quick analysis on the 2 registries that exist now for animal research and check whether they require reporting on the ARRIVE criteria. And you found that most things are addressed in these registries. So if you have the information, these are information you can then also copy paste, so to say, into the registries. However, we also try to identify a set of approval templates that we currently use in Europe to approve animal studies. And we checked whether the approval documents ask for information that reflect ARRIVE 10 criteria, because they would be important for registration. And here, with the exemption of Switzerland, in the templates that we had, these information were mostly not required. During the talk from Uli, I saw in the chat that somebody, Judith Homberg, I think, said, in the Netherlands, you are not allowed to conduct a study without randomization and blinding mentioned in the protocol. So it would be interesting to hear whether the templates already changed or whether this is something different. But from what we found, this is currently not matching very much. So this would be something where we have room for improvement. Last point, which is, so to say, on the top of our 3R value framework. Once we maybe address robustness, registration, reporting in animal research, of course, the ultimate value of animal studies is in presenting the available animal studies to the authorities for then approving a phase 1, phase 2 trial. Right? This is why we finally, or the last steps of basic and preclinical research. I say this because when it comes to this showdown of animal research, this is in the so-called investigator brochures. Here is the ultimate reporting of animal studies. The investigator brochures present to the authorities all the data you have, and then the authorities decide on whether you are allowed to translate into early clinical testing. We did recently first analyses of how animal studies are reported in investigator brochures, both preclinical efficacy studies and safety studies, and found that more or less you find no information in the investigator brochures about all the things that Uli mentioned in his talk. There is no information about randomization, blinding of animal studies, no sample size calculation reported. Even the sample sizes are often not reported. This is what we found with regard to how often sample size calculation is reported, blinded outcome, more or less never. And more or less all studies reported positive desired outcomes. So you could argue, yeah, sure, because why should people translate into phase 1, phase 2 if they have negative results from preclinical studies? But there are 2 reasons why we should concern here. First is we need, of course, preclinical studies that show us where the demarcation of our new drug, for example, is. When does the drug become negative? What is the dosage, the timing, where the drug isn't effective anymore? Because we want to do clinical studies in these areas where we have the best window of opportunity. With only positive results, it's very hard to review whether this is a good clinical study. Plus, if sample sizes were reported in these investigator brochures, they were about sizes of 7 or 8 animals per group. So if you have these small sample sizes, there should be negative results in your preclinical drug development. If no from them show up here, maybe false negatives, but there should be negatives. And if everything here is positive, there is at least the guess that there is probably a selective reporting going on. So saying, I want to state this because it's, of course, even if the academic field is doing everything fine, then we still also, of course, need the authorities and those people that finally plan clinical studies, that here again, we need to come back to these robustness and reporting measures and demonstrate that the preclinical studies we present are of highest value. Yeah, last slide. So I try to have, so to say, two lessons learned, that there is a set of 3 bigger areas: robustness, reporting, and the new thing, registration, where we can work very concretely, and we have ideas about how to improve the situation. By doing this, this is a practice of how we can safeguard the value of animal research. It's important for the ethics of animal research, and as Uli said, for the ethics of clinical research as well. But we will see that for some fields, we maybe even have to work on a little bit more conceptual, theoretic background. What does, for example, full reporting in animal research mean? We need guidance, yes. Then we need incentives from the institutions, from the academic centers. They have to incentivize and reward those people that work hard to make their animal studies robust and report them fully. And I think we can improve a lot in rewarding this in the current way that we plan and organize careers in the academic field. We need to support the researchers that are willing to do this. We even need training here. And then ultimately, of course, what I and Uli presented here are, of course, a lot of recommendations. Whether they turn out to be effective and efficient if we apply them in practice, such as registration, for example, needs, of course, a critical evaluation, and we have to refine and rework things to make them also efficient to be applied in animal research. Yeah. So far from my side. Thank you very much.
Well, we thank you very, very much. And I now open the last 2 papers for the discussion from the audience. You can raise your hand as well as you can write your question in the chat function. So there was one comment from Judith Homburg again, and she said, I think how science is organized, that means project-based, as well as animal research with tight regulation, slow down or even hinder in some cases the publication. For instance, it can be difficult to address reviewer comments if you do not have the ethical permission for what the reviewers ask. So
yes. Can I comment? So
yes, please, Judith, go on.
Yeah, so I really appreciate these 2 talks. I really very much agree, and it is really a mutual effort, I think, to get this better. Yeah, it's important to point out what we can do, and it is also good to realize that there are things that we can do. Yeah, so my comment is also based on we all have to apply for grants, and it lasts for a couple of years. And because it takes a lot of efforts to get the ethical permission, at one time point, the contract is ending of the PhD student or postdoc. And then you end up with data without personnel to finish it. And then you're already back into the next project. So I think that is not ideal. Perhaps, I don't know whether there is a solution, but would be good to discuss. But also, as I said, yeah, sometimes we face the difficulty that yeah, you have to add experiments, and yeah, you don't have any permission for it in your ethical permit, and then it takes months to get the permission for that particular experiment that the reviewer wants, or sometimes you just yeah, you don't get the permission. I really have some challenges there. So perhaps it is how everything has been organized that makes it sometimes challenging, even if you want to publish your data.
Okay, thank you. So who's going to answer to that comment? Daniel, really? One of you?
Well, maybe I can start. I think it's a fair point. And it's a tricky one. It opens the box of Pandora, because a lot of what we have been discussing or talking about is very tightly connected to how the system works. And you very soon, and you just found one of those positions where you get into conflict with how we organize our academic research. And another point, obviously, is the whole incentive business, how we value certain types of, is it excellence? Is it a Nature paper? Is it, I don't know, something that can be replicated, something that shares data, or data being used by others, stuff like that. So I think these are all issues we need to conceptualize, need to work on, and it's happening in various places. The Netherlands, by the way, I don't have to tell you, is very advanced in this. We're looking to your country to learn about what we can do. With respect to this very specific question that you have in terms of this conflict between the reviewer asks something and then you have to ask for permission, maybe Daniel has a good idea. I think that's actually a real problem for which I don't have a solution, because I believe in the value of having an ethical review, and it should be thorough, and then it needs some time, and sometimes it needs to be rejected because it may not be a good proposal and it may not be worthwhile. So yeah, there is a certain attention between these two things. In this grander scheme of life, meaning publication, doing experiments, I think it's a minor part. So I'm not so much concerned about this, but you are right. It shows that we're bouncing against the walls of the system. Yeah,
perhaps I would like to comment on that on some point later. But before, I would like to ask Francesca Cirulli. She raised her hand and does have a question. Francesca, if you please.
Hi, hello. Can you hear me? Yes, I really appreciated the two presentations, and I was struck when I saw that the arrived guidelines have arrived in a way, so that we are finally getting to the point where we look at animal research as if we were doing a clinical trial. I think this is really the key. We have to really relearn from clinical trials how we should really do animal research. The experience I have in Italy, for example, is that I review projects that are submitted to the Ministry of Health for approval for animal experimentation. So I know a lot of, what's the situation in terms of animal research in Italy. And what I can tell you is that what we look at is mainly animal welfare. So the issue that is under scrutiny is animal welfare, and the other very important thing we look at is power analysis, so the statistics. So we want to make sure we don't exceed in the number of subjects we are using. But as in terms of methodological details, unless they harm animal welfare, then they are not taken into account. So we really have to think that the directive, the legislation in terms of animal welfare should be probably, changed in the future, and it should incorporate this type of questions that we are talking about right now. Just because the focus is very much on the animal welfare. If the animal is fine, then the rest is not so. It's not so important, and it is. Because if we don't do good research, then it's not going to translate. So I think that there is a lot of work to do on this, in this sense.
Right. Thank you very much. And do you want to re-comment on that, one of the speakers? Not yet? Okay, then I would like to ask Anton Kulaga. He made the comment to everybody, and perhaps Anton want to speak on his concerns. Anton, if you please. No?
Just a second. Yeah, I am. Yeah, so I just had a question regarding this animal registry. And I mean, actually, it's kind of two questions. So the first one is that, I mean, even though everybody wants to have this register, but when you want to publish your data and register your study, there are people that have fears whether that this public data that they failed something will cause them trouble, or is that maybe, so there are some radical animal activists that even though the study is approved, they will make public noise and attacks on them. So that's a question about concerns for scientists. And the second thing, the main pain point that I personally have is that for many, there are some specific types of studies like health span and lifespan tests, as well as survival tests like toxicity, where people just report graphical curve and don't provide any tabular data, so the analysis on lifespan is not really reproducible. Is there like, are there any guidelines to actually have specific regulations for aiding data of survival experiments?
Maybe I can start by addressing your first point, and that I've heard that before, but I have to say I don't understand it, because what you're pre-registering is what you're doing and what you're publishing afterwards. So once you have published, I mean, if there are those crazy animal rights activists, and there are such crazy animal activists, I agree. What's the difference if you have pre-registered? First of all, you have made it only available after publication, and then it's published anyhow. So only if you plan to do stuff that does not get published and is sort of unethical, then you should be concerned about it. But I don't believe that is what you are insinuating. So I think this is not a real problem. And to your second point, what I think the solution to this, and not only for survival curves, but very in general, you're absolutely right. We always see these curves, and if we're lucky, they have a confidence interval. Usually they have a standard error of the mean, and then there's a bar. What we need is the data that is behind this. And I think the good news is here that many journals have understood this now, that funders have understood this now, and that there's a very strong push, and we have already reached some, at least to some degree, we have reached something here, that behind all those summary statistics, we get access to the original data, and then you can check it, you can do your survival curves or whatever. So I think what you're calling for is open data, and that's what we need. And then you have this advantage that you just mentioned, but we also have the advantage that we can aggregate data, make it much stronger. Other people may have even more brilliant ideas that we have with our own data, stuff like that. So I think that's the future, and the future is already here.
Well, yeah, I can add to that from the funder's perspective in two regards, and that is that this mental disorders call is the first call in which we as NEURON, as a funding network, have implemented the submission of a data management plan. So all of these projects submit data management plans, which we consider as a lively document. So there's the first plan you submit about 6 months after the project start, and you can update that every year if matters change, if you have different repositories and different output. But the final one is something we would like to publish in the end, yes. And the other thing is that, of course, with the with our project, we projects really do ask for the details for the animal experimentation, which are usually very carefully planned. Right, at least from our side, we do support strongly the entire the entire. Well, I must say I understand it more. It's a continuum of practices. It's a continuum of an idea and a continuum of practices, and step by step this can be promoted into the right direction. Right. So thank you again very much. You both agree that you're
sorry, a very short comment, because it's in our stakeholder interviews with regard to animal study registries. There were also this point with maybe animal rights activists could misuse these registries, but then there were also the points that Uli pointed out, that if they are interested in knowing what you as an individual researcher are doing, they can go to the publications and check. But a second perspective on this was that it's maybe not the animal rights activists who misuse registries, but people who make decisions about your career and who make judgments about your reputation. So people voiced the concern that, could it result into some damage of my reputation if people see that I have several studies that finally did not worked out or did not resulted into the desired results, and having such a CV of let's say failed studies could be problematic for my career. But of course, others also said that this is, I mean, if this is the case, then this is a very sad scenario. It of course should not be like this, right? This comes back to how institutions need to play their part. I mean, the institutions need to reward people if they advance our knowledge in a trustworthy and useful way. And this, of course, includes studies that finally did not identify the desired results. But if animal research is also still lacking, let's say, an error culture, then, of course, this is one of the barriers, the roadblocks that are in our way. But it's something we have to deal with, and then in parallel with developing the registries, of course.
Okay, thank you very much. We have been asked for the presentations, and Professor Dirnagl has already shared, and Professor Strech, it's fine with you for sharing your presentation, so we will make it public available on NEURON's website.
Sure, I sent my slides yesterday.
Yeah, you did send. We would transform into PDF and put a link to that then. Thank you very much. So we come now to a different part of our workshop, and you already know the brain plays a fundamental role in our psychosocial makeup, and so it's really natural that although ethical questions are not unique to neurotechnologies, they take on a greater significance when we come to debate them. Scientific and technological developments are crucial for brain research and treatment of brain disorders, so it is not surprising that exactly these gains in knowledge play a central role in the ethical issues and associated consequences from that research. We are thus delighted to hear today from the OECD Working Group the recommendations on responsible innovation and new technology. And as speakers, I have the pleasure to welcome Drs. Laura Kreiling and David Winickoff. They work on the Working Party on Bio, Nano and Converging Technologies, abbreviation BNCT, of the OECD. The Working Party is focused on policy issues in emerging technology fields related to bio, nano and converging technologies, and it aims to contribute original policy analysis and messages to the global community, to convene key stakeholders in the field, and to make groundbreaking proposals to policymakers. And with that, I hand over to Laura and David for their presentation. This is not yet
Yes.
full mode.
Okay, can you hear me?
Yes.
Okay.
Thank you very
go.
much.
Yes. Thank you, Hella. And it's a pleasure to join you today. I'll turn on my screen as well. Pleasure to join you today to engage this very interesting conversation that you're having about research ethics in neuroscience from a very early stage research, animal studies, and beyond. I'm going to talk today about a piece of work that the OECD has developed, and has actually, the OECD countries have adopted a piece of soft law and guidelines in the realm of neurotechnology. And the hope is actually to enroll you in a project that we now have, which is to how to specify, deepen, and use the recommendation to actually affect practice among researchers, among innovators and entrepreneurs and industry. I'll just say a couple of words about the working party that we're part of. We're in this Science and Technology Innovation Directorate. The OECD, just to recall, is an international organization of 37 member countries with advanced economies and democracies. Well, in some case, that's questionable, but certainly, you know, they traditionally are democratic countries. And in fact, they've come together since the 1950s when the development of the Marshall Plan came into effect. And the organization developed as a place where these countries could come together, administer the Marshall Plan, and later develop joint economic policies for better economic security and stability in Europe and beyond. And since then, it's an organization that works across Asia. Korea and Japan are the Asian partners. Many of the countries in Europe and United States, Canada, and Mexico, and a number of other South American countries. So our working party is really the group that deals with emerging technologies. And we look at the range of policy issues regarding research and development, innovation and commercialization, standards and regulations, ethical, legal, social issues, public engagement, education, skills and training, the organization of research, measurement and evaluation methods and tools. And some of the focal points are, how do we leverage emerging technologies to address global challenges? And one of the earmark ideas or concepts that are being advanced by the members is responsible innovation. So the Working Party takes as a central challenge to help create the conditions for the development and diffusion of trusted and trustworthy technology with broad and beneficial impacts for economy and society. And governance in emerging technology areas is difficult because, first of all, there's a pacing problem in a sense. These technologies are rapidly evolving with unclear impacts societally. AI is a good example. They can be disruptive to economy and society. Just think of the different business models created by digitalization, like Uber, et cetera. These technologies can possibly not fit well into existing legal categories. Neurotechnology is a case. Is it health? Is it consumer? And so forth. And they can enable larger areas of work. Now, when we talk about responsible innovation in neurotechnology, there are a couple points to make. Yes, we deal with innovation, and yes, we deal with neurotechnology. But I think of high relevance to this group is the fact that some of the principles, I think, bear directly on the development of the scientific base. And we'll get to in more detail on that, but I just wanted to show this slide because I think it shows direct hooks into what we've been hearing about. The need for open science, cross-sectoral collaboration. We see standards and best practices for technical as well as ethical, legal, and social aspects. I'm thinking of the development of the kinds of arrived standards and other kinds of standards that may be necessary around the use of animals or use of humans in neuroscience and neurotechnology. And this idea of the culture of open science, which we heard about earlier. Not to mention the development of joint infrastructures, which I think is relevant for the registries, the animal registries that our previous speakers have been talking about. So this slide is just meant to show you how these standards, this recommendation is relevant to you. And it raises the question of, can this recommendation actually do work for you to help you develop international cross-sectoral standards and so forth as you move forward in your thinking on this. It was a long journey to develop this recommendation. We had an expert consultation. We actually had also had another workshop in Washington at the US National Academies. And there was articulated the central point that there are unique policy questions concerning the technical, ethical, legal, economic, and cultural dimensions of emerging neurotechnology, and that these warrant a dedicated recommendation that address these diverse contexts. And I think that's some of why you're here as well, that there might be some exceptionality to neuroscience and neurotechnology that might warrant a special ethical treatment or regulatory or governance treatment. We had in September 2018 a large conference in Shanghai, China, called Minding Neurotechnology, Delivering Responsible Innovation for Health and Well-Being. And we aimed specifically to engage the private sector, neurotechnology companies or companies involved with digital mental health, and engage them in the conversation about what kinds of international guidelines or standards might be necessary. And in fact, it's interesting, we saw a picture of Tom Insel, because Tom, who, as you may know, went to the private sector after working for NIH, was our keynote speaker because he's developing, helping develop a company around digital phenotyping, looking at how we use our smartphones as an indicator for mental health. We then went on to an important drafting meeting at the Collège de France in Paris. And so stepwise became closer to the development of a recommendation. At the same time, we developed a body of analytical work to demonstrate some of the gaps in governance and some of the existing good practices that were going on at national level, with the idea that perhaps we could extricate broader norms, more general norms from these practices. So in December 2019, the recommendation on responsible innovation in neurotechnology was adopted, and it's accessible online with that link. And just a bit on the recommendation itself. First, what is an OECD recommendation? Well, it's an internationally agreed set of policy recommendations, principles, or best practices. It constitutes soft law, which means it's law, but it's not legally binding. It entails a political and moral commitment for national governments to conform to the recommendations. And there's this expectation and sort of shared norm that adherents will do their utmost to implement the recommendation. And furthermore, implementation is actually reviewed regularly so that countries have to report back to the OECD to tell the organization what they are doing to proactively implement the recommendation, which gives them a little more efficacy and bite than I think a lot of just general guidelines. And they tend to focus on peer learning and exchanging best practices. There are 177 OECD recommendations currently in force on broad range of policy topics from AI, water, and now neurotechnology. There's also one on ethical business practices and many on education and so forth. The principles in the recommendation are 9. The first is to promote responsible innovation in neurotechnology to address health challenges. And this might seem obvious, but the idea here is that this instrument wasn't just negative in operation, meaning it limiting certain activities, but there's a proactive norm that we should be promoting neuroscience and neurotechnologies for health, and that is a foundational point. And within that, we can talk about what kinds of innovation is necessary in terms of ethical innovation. But I think that's an important point and one that's key for understanding why this set of recommendations might be a little bit different than others. I should say, again, or also to that point, OECD, although there are policy issues in many different sectors, education, health, and so forth, economics stands at the core of the enterprise and healthy economies. And that's another reason why this wasn't a purely ethical statement in a way, or a set of ethical recommendations, although they could be seen that. It's also promotional for the kinds of actors who want to innovate to support healthy societies. Principle 2 is focusing on safety and the assessment of safety. Principle 3, the inclusivity of neurotechnology for health. And this involves a range of ideas about inclusivity in who is in clinical trials and in research, and making sure that different groups are represented, to issues of inclusivity of who gains or who gets access to technology on the other side. So that's played out in a number of sub-provisions. And that's a general point. All of these principles have in the actual text a set of sub-provisions that specify or give further, more specific guidance. Principle 4, which you've already seen briefly, is to foster scientific collaboration in neurotechnology innovation across countries, sectors, and disciplines. We have the enablement of societal deliberation. And I just point to the fact that deliberation was chosen, that word was chosen deliberately. It's not public engagement, but the idea is there's a need to create a space in society for actors to come and exchange and promote rational discourse about the implications of neurotechnology, and thereby feed into a democratic society. 6, the capacity of oversight and advisory bodies to address novel issues. One issue there is there's a sub-provision around the need to do foresight and forward-looking kinds of technology assessment to embody an anticipatory approach to governance. 7 is on brain data and other information. Principle 8 is around the need to think about the interface between the public and private sector, and the fact that there are ethical duties that span that potential divide. And finally, the need to anticipate and monitor potential unintended use and misuse of neurotechnology. To click on promote responsible innovation in neurotechnology to address health challenges, I just wanted to show you a few of the sub-provisions to see how it looks. First and foremost, promote beneficial applications of neurotechnology for health and foster research and development to further this aim. I think this gets one way, one could say that this might entail this ethical duty that we've heard about to make sure that, to ensure scientific quality. And so I think the idea that there should be benefits and learning from science is a foundational one, and that this applies to animals as well as to humans. Avoiding harm, showing due regard for human rights and societal values. And we highlight cognitive liberty, which is a new kind of idea in the discussion about neurotechnology ethics and neuroethics. And to prevent neurotechnology to affect freedom or exacerbate bias for discrimination or exclusion. So if you will, there are ideas that are deontological around liberty and privacy. There are utilitarian ideas around promoting benefit and managing harm. And there are distributive justice ideas around discrimination and exclusion. Back to principle 4, foster scientific collaboration and neurotechnology innovation across countries, sectors, and disciplines. So this is the principle that perhaps more than others focuses directly on research. And this is where I think where there could be direct engagement with the discussions that are going on and with the groups involved in the program today. The first is interdisciplinarity, and the idea that scientists and engineers should interact closely with social science and humanities, really in the generation of new knowledge, not just ex post or ex ante, but in the production of science. Also, fostering pre-competitive consortia of collaborative research. This gets at the need for open science. There's an overlap here with provision D. But the idea that we should be promoting these platforms like the registry and other kinds of collaboration across sectors, private and public, nonprofit organizations, and patient communities. I've already mentioned standards and best practices for technical as well as ethical, legal, and social aspects. And let me just spend a moment there. So here is where, for instance, it would be very interesting to get your groups and some of these perspectives involved. This instrument obviously cannot drill down into, let's say, a guidelines on the use of mice or other animals. But there could be a dialogue with this instrument and attempts to codify let's say, a set of guidelines. And this is going to be a living document where there may be practices that are collected and assembled on a web-based resource that can be searchable. And we can begin to connect these principles with areas of practice, and they can inform countries who want to implement these kinds of standards and best practices. It gives them ideas that, there's the Reeve guidance on the use of mice, and another country might pick it up and then show and report the fact that it picked them up for its health research to the OECD as evidence that these standards are being implemented. So it's a mechanism to connect development from the bottom up of guidelines, standards, and norms with the top-down level of requirements or norms for countries to implement these things. And in the middle, we think there's a kind of virtuous space that connects norm to action. Finally, the open science and joint infrastructures I already mentioned. I think this, as I said before, connects directly to things that have been mentioned, to open source, open access, open data. Those ideas could be developed further and could be important for showing that the registry could be a nice way to illustrate or find support in this call for joint infrastructures that countries are making. A little bit of conceptual stuff here. There's a problem in general with how do you, on the one hand, want to regulate earlier so that you nip problems around technology in the bud. But there are consequences of that because the consequences or harms of limiting innovation might not be clear. There might be misguided or inadequate regulation, or there might be unnecessary regulation. But if we regulate or govern later, changing course might become really expensive. Things are kind of baked into the technology. And Lawrence Lessig, the Harvard law professor, an expert on digital technology, famously said, "Code is law." And I think that gets that gets to the point of how we build, that technology is built in governance, and technology actually embodies ethical choices that are already made. And so to intervene in neurotechnology, we have to find that sweet spot of not going too early, but not going too late. And so this underpins an approach that might be called anticipatory governance. This upstream process-based approach basically aims to foster alignment of public support and economic incentives for neurotechnology innovation. This, as you know, this is a key aspect of the RRI, Responsible Research and Innovation program, of connecting innovation to real public needs and desires. Integrating ethics at the planning stage and design phase of technological development. So again, early on, planning stage and design phase. Promoting interdisciplinary research and development where communities of scientists and engineers interact. Again, this is building ethics and responsibility into the practices of innovation, into the practices of science. Support an international culture of open science by creating joint infrastructure and environments we've already seen. So I've pulled out just some key aspects of this upstream process-based approach. There are an expanding number of neurotech startups and firms, and this include NeuroPace, develops and manufactures implantable devices. They had raised, as of last year, 271 million. They've just raised 67 more million from investors. Neuralink, which you probably know about, the kind of the Elon Musk's company, which aims to implant a human-computer interface to treat and diagnose neurological conditions. And he conducted a ethically suspect experiment on a pig online, as you probably know. They've raised quite a bit of money, but he said, because he's the richest man in the world, he doesn't need to raise money. We're trying to convince people to come work at Neuralink. And MindMaze is a developer of a virtual reality and augmented reality motion capture game. They had raised 110 million, and they're continuing to get grants from government and industry. Future directions, are to develop the concepts of anticipation, inclusivity, and directionality for other kinds of technologies. So we're learning from the neurotechnology recommendation and case to apply this similar normative framework to other kinds of technologies. And that centers on this anticipatory stance that I mentioned, inclusivity, and the mission-driven or directionality approach. And finally, we wanted to just tell you about current activities to implement the OECD recommendation on responsible innovation. We recently had an event that was broadcast, in a sense, from Seoul with 14 countries and 47 institutions. We gathered ideas for how to implement the recommendation. We exchanged on experience and practices. And the creation of an implementation resource was discussed. The research community, I would say, was less represented at this meeting. And this is another reason why it's really important to connect with you at these kinds of meetings, to see if we can involve you as a key stakeholder in this work. And we heard about how the convergence of neurotech with other emerging technologies was very important, concerns on the use of brain data, and the need for interdisciplinary collaboration. And moving forward, there'll be a meeting on the 19th and 20th of May, nominally in Zurich, focusing on societal deliberation, safeguarding data and information, and promoting stewardship across public and private sector. And looking at, again, national efforts to implement the recommendation. So I'd like to thank my colleague Laura Kröling, and I think that's where we will end for today.
Oh, thank you very much for that presentation. And the paper is now open for discussion. And I had already seen one comment from Daniel Strech. Daniel, would you mind to raise your comment again?
Yeah, of course. Thank you very much, David, for this introduction and this presentation of these principles. I saw this principle 2 saying that there should be a priority for safety. And this is just something that I heard back from regulatory authorities that have to decide about whether we are allowed to conduct new trials with humans on new potential drugs. And they often say, we prioritize an assessment of the safety of new drugs. But what we talked about in the first 2 talks is the dilemma that we are often bringing maybe potential new drugs into testing with humans, maybe also neurotechnology, of course, that has a flawed basis with regard to its potential efficacy. Mm-hmm. So having a priority for always only assessing safety and putting the efficacy, the potential benefit only as a secondary priority might also, of course, cause some of the problems that we discussed earlier. So now I assume that with your second principle, you probably did not mean this, but it could be seen like this from people I spoke with. So I wanted to hear your comment on this, whether it really means that priority of safety is then meaning efficacy of new technologies is of secondary interest.
I think it's hard to avoid that safety is being presented as prior. Although I think if you read what I said before, if you read the provision around safety together with these strong statements about the need to promote beneficial applications of the technology, I think you easily see, and perhaps the group of countries could have been more explicit about this, that the that there's duties to push, actually push through, through new therapies, and if one wants to that are efficacious, that actually have an impact on society, and I think that that's the thrust of the entire instrument. But I think you're right. I think the group of regulators and countries tend to stress safety over efficacy.
Okay, well, thank you very much. That answers the question. I would like to point out another point that was on one of your slides, that is changing course may increase necessary resources. And that is something that we also should consider as funders. NEURON is a network of funders. So if we want to have more considerate or more detailed experimental planning, that may lead to more expensive applications. And also open science might cost quite a lot, because costs increase when you share your data. You need to store them and you need to curate them. There might be IP issues. There should be a noise to signal ratio or findability. All these matters do cost. How is your view on the additional costs? Because as you know, we are spending taxpayers' money, and we are therefore responsible, and we cannot fund endlessly. Or
Right.
our costs are usually highly competitive anyway.
Right. Well, this is a general dilemma about public goods and global public goods, and that in fact individual countries may not have the direct monetary incentive to follow a certain behavior, and yet if everyone did so, the benefits would spill over for everyone else. So I might say something like, well, if there's a joint commitment to open science as there is in the instrument, perhaps the German or other researchers receive benefits from open science, and maybe it makes their research more powerful, more useful for society. So there are costs and there are gains. The problem is it's hard to quantify the gains when it's kind of easy to quantify the cost because it's in the grant application.
I agree. Yeah. But the incentives are on the ethical and the moral commitment, and in general in the better science, I would say.
Yeah.
So a joint investment will pay off.
I think that's right. And so that's why it's up to international bodies like the OECD or like UNESCO or like other international scientific communities to generate the kinds of collective norms that can rally and support this type of collective thinking and collective action.
Well, thank you very much for that comment. That was really enlightening. Are there any other comments or questions from the audience? Not okay. So then I would really like to heartily thank all the presenters in this workshop. That was a very dense and ambitious program, and thank you also for sharing your presentations. And so I can close this session now, this workshop, and for the attendees, for the audience, for the EBRA NEURON Symposium, we will resume at the main room at 4:15.